Okay, students, in this section, we are going to discuss the hydroxylation of alkenes. What is the meaning of hydroxylation? Hydroxylation means addition of two OH group across the carbon-carbon double bond is called as hydroxylation of alkenes. Okay, or we can say that when the alkenes are converted to the vicinal diols. So what are vicinal diol means? The adjacent carbon atom, they are having the two alcoholic group are called as vicinal diols. Okay, or 1,2 diols are called as uh, hydroxylation. Okay, so how to convert an alkene to a vicinal diols? Okay, so it is possible by using some of the reagents. We call that reagents hydroxylating agents. Okay, there are plenty of hydroxylating agents are available, but here we are going to discuss with the two reagents, that is alkaline dilute potassium permanganate, or it is also called as Bayer's reagent. The Bayer's reagent we are going to use in the qualitative organic analysis. Okay, so the Bayer's reagent is nothing but alkaline 1% KMnO4 solution is called as Bayer's reagent. This is one of the easily available reagent. And one more thing is the osmium tetroxide. This is also a hydroxylating agent. Okay, so there are plenty of reagents are available, but we are not at all going to discuss the topic. Okay, mainly we are focusing on these two. Okay, so how these osmium tetroxide as well as KMnO4 converts an alkene to a diol. Okay, so first what happens, the alkenes undergo addition with the osmium tetroxide or with the KMnO4 reaction, KMnO4, to form a inorganic cyclic ester. Okay, we can discuss detail in the mechanism. Okay, so cyclic inorganic ester it is going to form. Then on subsequent hydrolysis, we have to do the hydrolysis to offer the hydroxyl groups on the adjacent side. Okay, so then we discuss what are the advantages and disadvantages of these two reagents. Alkaline dilute KMnO4, it is easily available, that is the advantage. Easily available. And another thing is it offers very low yield, that is the disadvantage. Okay. When it comes to the matter of osmium tetroxide, of course it offers a very good yield compared to the potassium permanganate. The thing is, the disadvantage is it is highly toxic in nature and it is expensive, highly expensive reagent it is. Okay, so these are all the advantages and disadvantages of these two reagents. Okay, so next we move on to the how it forms the 1,2 diol. What is the mechanism associated with this? Okay. First, what happens, the alkene being an electron rich compound which attacks the oxygen atom of this one, because here the osmium is in the highest oxidation state. Okay, it is always try to pull the electron towards itself for oxygen atom. That's why the nucleophilic alkene which attacks over this oxygen atom, as a resultant of this one, the electron moves in this way. Then this oxygen again which attacks the carbon of the double bond. Then it forms a cyclic inorganic ester. Isn't it? C double bond OR is called as ester group. Okay, so here it is this cyclic inorganic ester is formed. So it shows a transition status. Transition state means the carbon-carbon double bond is about to leaving and carbon and oxygen bond is about to forming. Okay. And this cyclic intermediate, it is possible to isolate it. Okay, that's why they proposed this mechanism. Then what happens? This is the exact cyclic intermediate, it is formed. Then, which undergo subsequent hydrolysis. What is hydrolysis? The water molecule which adds to the osmium double bond O, that is to the osmium, then this bond is going to polarize. Okay, then it forms. So when the water nucleophile attacks on this will forms the intermediate. So that what happens here, the whatever the bond that polarizes here, C double bond O, it will come back, and again the carbon oxygen bond O, which picks a proton from this one, which leads to the carbon OH bond is formed. Okay. So in this side also, okay. So here there are two carbon and oxygen bond is there. Okay. Again it undergo one more hydrolysis by using the water molecule. The same step, whatever it is here, it is repeated for this carbon bond oxygen also, and ultimately we will get the product of 1,2 diols with this is the osmium tetroxide is connected to the hydroxide. Here what is the oxidation state? Here it is the +8 oxidation state. Here it is the +6 oxidation state. We can say this undergo reduction. The carbon-carbon double bond which undergoes oxidation means addition of oxygen takes place here, and reduction of osmium from +8 to the +6 happens here. Okay, this is called as hydroxylation of alkene. And one thing we want to tell about this hydroxylation of alkene, the addition of since it forms a cyclic inorganic ester, the addition of two hydroxyl groups which happens in the same phase. Okay, so when the two hydroxyl groups are adding in the same phase, we called this one as syn addition. In the previous video, we have discussed about the hydrogenation. There also metal catalyst which they are providing the hydrogen from the same phase. Okay, in the similar way, the hydroxylation of alkenes, okay, by osmium tetroxide, or you can do it with alkaline KMnO4. There also the similar mechanism is going to follow. The addition of two hydroxyl groups takes place by the same site. This is called as syn addition. Syn addition which leads to a syn diols. Okay, so stereochemistry we can discuss in the next video, isn't it?